Hi, my name is Markus Tatzkian, and I'm a professor at the Salzburg University of Applied Sciences in Austria. I will present a paper exploring input approximations for control panels in virtual reality, written together with my co-author Christoph Birkmann. In this work, we investigate the manipulation of control elements, such as buttons and knobs, in virtual reality with the goal to support more complex training tasks involving the manipulation of machinery and equipment. In contrast to more sophisticated VR training simulations such as flight simulators, we do not rely on physical replicas of control panels, but only use currently available VR controllers. Because we use standard controllers, we must map articulated hand interaction to input approximations that rely on the buttons and joysticks of controllers. We implemented 3 input approximations for real hand input to manipulate control elements. Our baseline input method uses raycasting for selection and activates controls using the trigger button. The second method, the joystick input method, also uses raycasting for selection, but uses the thumb on the joystick for potential fine motor adjustments of the control elements. The third input method relies on the feature of current VR controllers to form rough hand gestures using capacitive sensing. This allows us to use roughly approximated but reliable hand gestures, such as pointing or pinch gestures, to manipulate controls. The following videos show the manipulation of the slider control using our input methods. Users must set the slider to a specified target value, and once set, the red indicator above the control turns green. Using the trigger method, users select an element using raycasting and move their hand to set the target value. For the approximate hand method, users activate the slider using a pinch gesture and then move their hand to set the target value. Hence, the manipulation step of approximate hand and trigger method are very similar. Using the joystick method, users select the slider using raycasting and manipulate it by tilting the joystick in the corresponding direction. Hence, users avoid gross motor hand motion after selecting a control and rely on fine motor manipulation using their thumb. More example videos as well as detailed explanations can be found in the paper and supplemental material. We performed an experiment to explore the performance of the input approximations for different control elements. Independent variables were the 3 input methods, trigger, joystick, and approximate hands, and the 4 control elements button, toggle, slider, and knob. Dependent variables were task completion time, physical effort, mental effort, and usability that were measured for each input method and control combination. After finishing all trials for a control using all input methods, we also asked users for their preference. Participants had to perform a simple task where they set a highlighted control element to the indicated target value. The task was repeated 9 times for each control element and input method. Our results do not show a clear preference for a single input method. Therefore, we will discuss the main findings separately for each control. You can find a more detailed discussion of the results in the paper. The trigger method performed consistently well across all control element manipulations and was ranked highly by users. You can see here that it outperformed joystick and approximate hand method for the comparably simple button control manipulation in terms of task completion time. The difference between input methods becomes more apparent when looking at the more complex interactions, such as the toggle manipulation. Here the approximate hand method was clearly outperformed by both joystick and trigger method. We believe that the approximate hand method performed worse because of the implemented physical manipulation of the toggle element. Users had to push the toggle beyond a certain threshold using their virtual hands until it snapped to the corresponding state. Even though joystick was not the fastest method, it was still well received by users. This may be an indication of the intuitive mapping of the joystick geometry to toggle elements. For the slider element, the joystick outperformed the other input methods and was also preferred by users. Here the fine motor control of the joystick may have had an advantage over the other methods. In contrast to joystick, trigger and approximate hand method manipulate sliders using gross motor forearm movement, which may make it harder to set the target value. For the knob element, trigger and approximate hand method outperformed the joystick method. This is in direct contrast to the results for the slider manipulation. We believe that the fine motor control using the joystick could not fulfill its potential in this case because of one of our design considerations. Based on a pilot study, we implemented an activation step where users had to tilt the joystick into the direction of the currently set value of the knob. This had the goal to force users to perform a rotating motion using the joystick. In hindsight, this activation step made the manipulation more complex and ultimately put it at a disadvantage in comparison to the other methods. Preference also clearly shows that the joystick method was disliked by users. The approximate hand method actually was the preferred method and had a high usability rating. In summary, in this work, we demonstrated the potential of different input methods that approximate real hand manipulation of typical controls in virtual reality. The baseline trigger method generally performed well, but results showed that joystick may also be well suited for fine motor manipulations required by sliders and knobs. The approximate hand method showed its potential as it was not always outperformed by other methods and preferred for at least one control element. Further optimizations of the input methods may reduce the drawbacks of the presented methods. For instance, simulating physical manipulations, as done for the approximate hand method for buttons and toggles, should be avoided. As future work, also more complex tasks resembling actual training tasks should be investigated. This will allow us to measure the cognitive overhead of using these methods in more detail. This concludes the presentation. Thank you.